All right, so let's take a look at your Unit 2 exam key. There were, as I said in lecture, there were, let me see if I can get my drawing tool up here, 31 multiple choice questions, each worth 1 point apiece. There were 10 vocab questions, each worth 2 points apiece. Let's see, 21 divided by 3 is 7. There must have been 7 short answer questions, each worth 3 points apiece. There were 72 possible, and I took it out of 65. So that hopefully benefited everybody. So the first question was in regards to the relative size of Jupiter, and the best answer there is which of these is correct, and the answer was B. It is correct that if Jupiter were 75 times larger, it would have actually become a sun and would have been a companion to our sun. A, C, and D were incorrect, and that was kind of maybe one of the trickier ones on this test. I'm trying to get it to center or to kind of straighten up, but I guess this is as good as it's going to be. Question number 2, how do we know what the surface of Venus was like? And actually the best answer there is D, that we used radar technology because we can't actually see the surface of Venus, but we can penetrate the thick clouds using radar and look at that kind of what we call reflectivity. Question 3, what's the source of the Galilean moons, Io, for it being so warm and having kind of like these little volcanic activity? And that is actually as Io orbits the planet Jupiter, excuse me, it kind of is elongated and squished, and that heats up the cute little moon. Question 4, how do we describe the surface temperature of Mercury? And the answer there is extremes. The daytime side of Mercury is very hot, but the nighttime is extremely cold. Remember, because it has no atmosphere and it rotates so painfully slow. The last question on this page was those spectral lines, which actually we're going to revisit those spectral lines when we talk about stars in general. What creates those spectral lines are electrons transitioning. We get bright spectral lines and dark spectral lines. All right, on the next page, question 6. I had several questions on here, features of things on planets, and Olympus Mons is actually on the planet Mars. That's that kind of what we call the big caldera, kind of like a volcano about the size of the state of Missouri. Question 7, which one of these actually summarizes in Wien's law and Stefan Boltzmann's law what happens as an object becomes hotter? And C is the best answer there, that the wavelength will become shorter. That's the more energetic colors. And then the intensity of the energy will increase. And again, we use this with stars too. Question 8 was a question about Saturn's rings, and letter C there actually shows the ring pattern from closest to the planet outward. We have the C, B ring, then Cassini division, that's the one we see through the telescope, excuse me, A ring, Encke division, and F ring. Question 9 was a question about the greenhouse effect on Venus, and the best answer there is D, that, let's see if I can shrink this up. Okay, yeah, the best answer there is D, is that on Venus, that it is actually the presence of carbon dioxide in Venus's atmosphere that acts as a blanket and traps the heat that the planet gets from the sun. Question 10, Venus actually has what we call retrograde rotation, and this means that it actually rotates clockwise instead of counterclockwise in its axis of rotation. Now, Venus, like the other planets, does orbit the sun counterclockwise, but it spins or rotates clockwise, okay? All right, next page, question 11. This is a date. There are some dates in astronomy that I think are important, and this is one of them. So 4.6 billion years ago, our sun turned on, and it began this what we call solar wind, going in all directions. Remember, kind of cleared the plane of the ecliptic, and what wasn't stuck to a planet was kind of blown away. So kind of not blown away, but kind of blew away. So 4.6 billion years is how long our sun has been converting what we say hydrogen into helium in its core. So question 12, which of these is a true statement about Saturn's rings? And B, it's true to say that Saturn's rings are made of these kind of reflective icy rock fragments. So remember, it's not like a solid sheet. Question 13, in lecture, we saw a photo of this hexagonal shape at the North Pole of the planet Saturn. So that's pretty cool. Six-sided shape in Saturn's clouds. at its north pole. Question 14, and I know it was red for a few of you and black for more of you. Actually, I was after a reflecting type of telescope. So reflector was the type of telescope we were looking into because you could look down at the back of the telescope and it had a mirror. Question 15, binoculars are most akin to refracting telescopes that use lenses. Question 16, the gas giants in our solar system, actually, they all have moons, right? And the moons actually that orbit the gas giant planets are kind of similarly formed as the planets that orbit the sun. So that's kind of, this B is what I was after there. They what we say accreted and kind of snowballed in place orbiting the planet. All right. The next question, which one of Saturn's moons is the second largest in our solar system? And it's also one that actually appears to have an atmosphere, and it rains liquid methane. And the answer there is Titan, not to be confused with Triton. So Titan is one of Saturn's moons that we have actually landed Huygens on spacecraft on. Question 18, which of these is not evidence that that liquid water was once present on the planet Mars? And so actually B, C, and D are correct. They all are evidence that water once flowed on Mars. A is not correct. There are no clouds on Mars that actually rain liquid water. So, question 19, the Great Red Spot is associated with the planet Jupiter in the clouds of Jupiter. Question 20, which of these have a surface feature referred to as Miss Piggy, and that would be the planet Venus. Remember, those are kind of like the squished volcanoes. Venus looks, we might go back to Venus one of these days. Which of these have no moons? And actually Jupiter has moons, Earth has one moon, Mars has two moons, so Venus has no moons. Question 22, this is a question about the difference between our inner rocky terrestrial planets and our outer gaseous Jovian planets. And what separates them, according to temperature, is what we call the frost line. All right. So the next question, according to the Doppler effect, and we will be revisiting some of these later on in the course, the Doppler effect actually, if the source is moving very quickly towards you, then those wavelengths of what the source is emitting are going to be squished together. Okay, so wavelengths are going to be squished together, shortened. So that means, and this was maybe one you had to kind of think through, but if something is emitting green light, I'm going to go ahead and do this. Roy G. Biv. All right, and I'm going to put short here, short wavelength. Oh, that's terrible. I'm going to put long wavelength here. So green is here, okay, and if the object's moving towards you, it's going to go if it's moving towards you, it's going to go towards the short region of the electromagnetic spectrum. So here you go. It's going to be called what we call blue shift, and it will go from green to blue to indigo to violet. So that was the BIV there. Question 24. A planet that orbits a different star than the sun is called an exoplanet. So B is the best answer there. I think that protoplanets, remember, are actually baby planets, planets that are still accreting or snowballing. An exoplanet is a planet around a distant star. Exoplanets are more popular than even protoplanets. I know I showed you a lot of protoplanets in Orion, but exoplanets are even more popular. Question 25, which of the following planets in our solar system has the fastest moving winds? And the answer is, and actually it's kind of weird that it is so, but the most distant planets, Neptune, has the fastest moving winds. Question 26, the closest Galilean moon to Io has an odd looking surface. It's kind of yellowish due to the presence of sulfur containing compounds. Question 27, this is a question about Venus, and Venus actually has, we think those thick clouds actually do release, it has a precipitation cycle, or just in those thick clouds that in addition to carbon dioxide, there is sulfuric acid. This is one of Neptune's moons, and it's the Cantaloupe one, and so actually it is the moon called Triton. Question 29. The planet Uranus has a strange tilted axis of rotation. And how did we see then, kind of related to its tilt, how did we see its rings? And so C is the best answer there. We actually could see light from a distant star, and that light from the distant star was blocked out as the Earth orbits the sun, and we could see kind of the distant star. What we use the word occulted means to have the light blocked out. So which planet was discovered by deviation of actually the planet Uranus deviated from what we say that Newton said it should be as it orbits the sun, and it was showing the presence of the planet Neptune. Question 31. Scarps are found on Mercury, and they were most likely formed as that small, remember, think of pizza. Mercury's pretty darn small. It cooled quickly, and actually it cracked, kind of like actually you might have seen sidewalks crack. Sidewalks crack because they expand when they're hot and contract when they're cold. So that's what formed these scarps features on the planet Mercury. So D was the best answer there. So we're 2 points apiece. Here's your vocabulary questions. I was after angular resolution, and I took kind of an assortment of questions. Remember, these are each worth 2 points apiece, so it's possible that you got 1 of 2 points. But angular resolution is the quality of the telescope that allows us to see detail. So the smaller the angular resolution, the better. Question 44. In order to capture long wavelengths like radio wavelengths, we need to have multiple telescopes kind of combining their signal in a technique we call interferometry. When the sun turned on, it created this outward blowing wind that we call solar wind. Question 35. Mars has 2 relatively homely moons, and you could either said Phobos or Deimos. Only a planet could love these moons. The whole salad dressing thing, the thing that when the planets were still ooey gooey, that the heavy things sank and the light things rose, that's called planetary differentiation. Then we go on to the next page. I was after accretion for kind of the snowballing effect that as our sun was forming and the planets were forming kind of in their tracks when they gathered material to make the planet, that's called accretion. Caloris Basin is the impact crater found on, I'm going to use basin, impact basin or crater found on Mercury, so crazy of a strong impact that jumbled the rocks on the other side. Twinkle little star actually is what stars do from our perspective, and that's related to blobs of air with alternating temperatures moving at higher elevations, moving between us and the star. Adaptive optics kind of creep me out, but it's where your telescope, and I don't have one of these obviously, but it's segmented so that actually the telescope can reshape itself depending upon what the twinkling or what the atmospheric turbulence is. And then I was after solar nebula is that cloud of gas that created the sun and all the planets, the little chunk of gas that created us and all. Question 42. You could, to answer this one, I was after you to tell me something about how spectral lines are created. Of course, they're created by the electrons. And I wanted you to mention what happens during absorption lines, what happens during emission lines. And so this is what happens during absorption lines. Actually, we have the nucleus of an atom. And during absorption lines, electrons are excited and energy is sucked in. Then during emission lines, these are bright lines. These were dark lines over here. Absorption lines, emission lines are bright lines. Actually, what happens is an electron, again, is at a higher energy level, and it falls back down, and it emits light. I don't have these here to show you, but this was the slideshow or the images of these planets. The biggest, the biggest mistake I saw, and I didn't say that they were all planets, but a lot of you, and I can see why, said that the picture of Mercury looked like the moon, and I can totally see why. So these were each worth 3 points apiece. So it's possible that if you said the Mercury was the moon, that you still got 3 points. That's just kind of how it works. Question 44. What happens to a piece of metal if you heat it up? And I wanted you to tell me with regard to color and with regard to light intensity. So to get all 3 points, I'm pretty sure I was consistent that to get all 3 points, you had to answer both of those questions. So it will glow brighter, and then the color will change from the long wavelength to the short wavelength of light. Okay, and it would even keep going, getting hotter, getting shorter wavelength than yellow. So here for 45, I was after geological activity, and this is maybe kind of a hard one to sink your teeth into, I'm not sure. But they go, excuse me, back to the pizza thing. A small piece of pizza, like we have with Mercury and maybe even Mars, is going to cool quickly, and it's what we say geologically dead. And then a large piece of pizza, which would be Earth or Venus, actually is going to cool more slowly, and it's still got some liquid ooey gooey, and we can have what we call plate tectonics here on Earth. So question 46, I was after two things. I wanted you to list those cousins, and there are 7 of them. So we have visible light, dead center, and then shorter than visible light, we have UV, X-rays, and gamma rays. Longer than visible light, we have infrared, microwaves, radio waves. That's 7. And then I also wanted you to say something with regard to frequency. So gamma rays are the shortest wavelength, the highest frequency, and radio waves are the longest wavelength and the lowest frequency. So here, on to question 47. So for question 47, I was asking for a little bit of information about terrestrial planets versus Jovian planets. Compare and contrast. So terrestrial planets, for instance, things we can say is they're closer to the sun, they're relatively small, they're rocky, they're dense, and they have limited moons. Compare that to Jovian planets. They're farther from the sun, they're relatively large, they're gaseous, they're not rocky, they have low density, and each of them have moons and rings. So for number 48, and if I was picking ones to answer, I would pick this one. So I wanted you to draw major features of a wave. And so we have peaks for a wave, and then we have troughs for a wave, and then from peak to peak or trough to trough is what we call the wavelength. So I was looking for those 3 things. For 49, it's about to the planet Uranus, whose axis of rotation is tilted, so it lies basically in the plane of the ecliptic as it orbits the sun. So this would be the sun here, and I'm showing the planet counterclockwise, right? Orbiting the sun, so that's Uranus. And since its axis of rotation lies in the plane of the ecliptic, this would be when North is experiencing summer, and then half a year later, North is experiencing winter. But it's even more crazy extreme than our North Pole. So somehow like that. And then for the last one, good job. I enjoyed seeing your diagrams, the ones who chose to answer this one. So this would be a refractor, a refracting telescope, and it uses a lens. And we have the light coming into a focal point. And then there are different types of reflecting telescopes, but what they all have in common is this is a mirror over here, and it happens to have this kind of what we call concave shape, and it takes the light and it brings the light back to this is my focal point. So we have light coming in and light actually what we say converging to a focal point. And that packed up light is what we then look at through our eyepiece. So let me know if you have any questions about this unit exam. Make sure that I added up all the numbers right. So at the bottom of pages that kind of denote the 3 sections, multiple choice. Of course, multiple choice I don't write, but I do for the vocab, and the short answer should be a number down here, and that's the number that I added at the front of your test booklet. So keep me posted.